Hey boys and girls, Mr. D here. So, after watching this video, hopefully you'll be able to have some more confidence in completing the square to factor your quadratic trinomials. Really, the purpose of this video is a little different from a lot of the other videos where we provide notes. In this one, we're going to be reviewing some questions that I've asked you to solve as an assignment. So, some of you may have had some problems in some of them, maybe some of them were easy. Whatever the case may be, hopefully after watching this video, you'll feel much better about everything. Okay, so let's take a look here. Uh, found this little cartoon here. For those of you that are a little confused by this is the caveman who lived a long, long time ago. We were talking about Haran and some of his discoveries, some of the mathematical discoveries of the ancient times in Alexandria, Egypt. And this is just a comic. This is not how it really happened. They were not working on completing quadratic, trinomial, perfect squares here. Just a little humor. All right, anyway, moving on. So we're looking at page 579 in the textbook. In these first several problems, the directions, they just ask us to find the value of c so that each of these expressions would be a perfect square trinomial. So really, we just got to do our little magic potion part there where we're looking to take half of b. So again, the whole magic part to make it a perfect square trinomial is take the b value divided by 2. Okay, and then we have to square that whole thing. So in this case, our b value is 18. So 18 divided by 2 is 9. 9 squared is 81. So for number 7, all your answer has to be is, hey, c equals 81. Okay, they're just looking for the c value to make this a perfect square. That's all they're looking for. And number 8, our b value is 22. Half of that, cut that in half, it's 11. 11 squared, well, you guys know that. That's an easy one, 121. Here we've got negative 30. Cut it in half, it's negative 15. 15 squared is going to be 225. All right, number 10 and number 11 pose interesting scenarios. And number 13 that we're going to get to in just a moment is similar to this, where our b value is odd. So we're all intelligent people here. If we take an odd number and cut it in half, we don't end up with an integer. So for example, I have 5 over 2. Actually, negative 5 over 2. I'll just ignore the negative sign because I'm going to square it, so it's going to be positive anyway. Let's just take 5 over 2 squared. Now, what we could do is we could say, hey, 5 over 2 is 2.5. All right, then we could take 2.5 and go 2.5 times 2.5. And then we start getting into the decimal 6.25. And then that's not really going to help us in completing the square because then our c value is 6.25. And some of you are going to scream at me and say, that's not a perfect square, blah, blah, blah. So think about this. Just keep it as terms of a fraction. If we multiplied this out, then we'd have 25 over 4. If we use this as our c value, could this be a perfect square? Uh, yeah, absolutely. If we take the square root of the top, it's 5. Square root of this would be 2. It would bring us right back to this. So this is a perfect square. So this would be our c value. So same thing here. Think about what this would lead you to. 17 over 2. Okay. And then square this out. You guys know 17 times 17 is 289. And the bottom there, the denominator would be 4. So that's our c value. Okay, over here, half of 4 is 2. 2 squared is 4. So c equals 4. Okay, so again, we use b, the formula b over 2 squared, we use that to find out what our c will be to make it a perfect square trinomial. It's sort of like the magic dust, the magic beans that make this whole thing work, okay? So let's take a look at number 13. 13, probably the toughest one of all of them. I probably should have told you guys this one last. I apologize. If we look here, our b value is 7. So we talk about finding our magic potion. We're talking about 7 over 2 squared. Again, fight the urge. And this is where some of you probably ran into trouble. You probably cut this to 3.5 and then multiplied this out and probably started to cry or saying bad things about me. Leave it as a fraction. Okay, leave it as a fraction. Your new C value is going to be 49 over 4. Okay. So, by the way, before I get any further, let me first address this. If this was your issue, if you put this into a decimal, what I would suggest is pause the video right now. Try and work the problem out. And do it as a fraction. Don't divide out any of the fractions. Leave them in fraction form until the very, very last possible moment. Okay, so if you didn't try this problem as 7 over 2, try it as 7 over 2, plug in 49 over 4, use that as your C value to complete the square. And then if you get stuck, turn the video back on. I'm going to go step by step. So try not to let me expose all the answers to you. See what you can do. If you come to a bump in the road, refer back to the video. Only for what you need. Pause the video and try and finish it on your own. Come back to the video when you need some help, okay? Keep that in mind for all of these problems, okay? So some of you might be pausing the video right now to try this out. And then let's move forward. Come back to me when you need me, okay? So the next step, we'll fill in here g squared plus 7g. We're going to add in our new c value right here. 49 over 4. Remember, what you do to one side, you got to do to both. So we get 144 plus 49 over 4. We're going to have to simplify this. And again, like I said before, leave these as a fraction for now. Okay, don't divide this out till you really have to. I'm going to change up colors here just because we're getting... I'll just separate this here like that. How's that? Alright, so here, let's factor this left side now. Look, this is a perfect square. A is a perfect square. C is a perfect square. And it's positive. So let's do this. So G, take the sign of B, which is plus. Perfect square here is 7 over 2. And this whole thing is squared, quantity squared. Over here, we're going to get into a common denominator. Okay, so I'm going to make my common denominator 4 for this. 144 times 4, if I work that out, and you can work it out on the side if you need to, I've already done it ahead of time. For me, it's 576. So what you end up with here is 576 over 4. And feel free to pause this and continue on your own at any time. Come back to me as you need it. Okay? You guys should know how to do it from here. If you got stumped here, and pause it and continue trying to do it on your own. Okay? So here, common denominators. Right? Combine these up here. So if we simplify this right side of the equation, we get 625. This is going to become 625 over 4. If you start to look ahead, this is going to work itself out nicely, I think. Okay? G plus 7 over 2, quantity squared. Alright, so we've added our c to both sides. Right, we added our new c to both sides. Okay, we simplified this right side. On the left side, we took our new perfect square trinomial and we factored it out. So now, if you look, we've got something being squared all alone on one side. Here's where we just take the square root of both sides. Okay, so this is going to unlock over here, so it's just g plus 7 over 2. Remember, anytime you take the square root of something being squared, it just cancels out the exponent. Just over here, again, this may look funny. Again, break this up. So you really have the square root of 625 over the square root of 4. You can do that. Okay, same thing. You're allowed to do that mathematically. Okay, you're not changing anything. The square root of 625 we know is 25. The square root of 4 we know that is 2. Okay, we got to make this plus or minus. So here's where we set up our two equations. G plus 7 over 2 equals positive 25 over 2. over here, g plus 7 over 2 equals negative 25 over 2. All right, let's get our variable alone. So you subtract 7 over 2 from both sides. So g equals 25 over 2 minus 7 over 2. 25, we already got common denominators, which is great. 25 minus 7 is 18. 18 over 2, well, that's just going to give us 9. So g equals 9, and let's simplify over here. G equals negative 25 over 2. There you go. Minus 7 over 2. Again, we got common denominators. Negative 25, negative 7. That gives us negative 32. So negative 32 over 2 is negative 16. There's your two answers. So again, when we talk about these numbers, what they represent is if we went back and graphed this original quadratic equation, these would be our x-intercepts. Okay. What I'm going to do right now is I'm going to stop this video, and I'll make part 2, in which we'll go over numbers 14, 16, and 18, because we're running out of time here. Won't allow my video to be too much longer. So I'll make a new video for numbers 14, 16, and 18. Hope this was helpful. Okay? See you in the next video.